there guys, welcome back to another video. So today I'm going to be talking to you more about some electrical components which you would see in a motor vehicle. So to start off with, I'm going to be talking about some alternators. And the main purpose for an alternator is to charge the battery. These are typically mounted on the side of the engine, where you would also have a belt on the pulley, which will be driving the alternator as the engine is turning, which can then generate some power to then charge the battery to keep it going. So here are some of the many components within an alternator. So the regulator, which you can see, the regulator's main job is to supply the current to the rotating parts of the alternator. It also controls the amount of current in a rotor, which is known as the field current. The rectifier itself, which is just mounted on the back of the cover, is it's actually there to rectify the amount of current that is going through, as well as to change it from AC to DC. And it does that by using some diodes, which are in there as well, to allow the battery and other electrical components to work off the DC current. AC does stand for alternating current, and DC does stand for direct current. So I'm going to be talking about these two main components here at the same time, which are the stator and rotor. And the reason why I'm going to be talking about both of these at the same time is because both of these components do in fact work together to generate the power, and alongside what else I'm going to be talking about as well. So the stator and the rotor, these two components do actually work alongside each other, as I did say, to generate the power. It does this as the engine rotates, and the rotate itself spins past three coils, which then you can see right here as well. These are the coils, and these are actually fixed to what's called an iron core, in which makes the stator. So that is pretty much how an alternator works, along with all the components which are inside of it. And obviously the pulley, that is where the belt will go onto, which then spins the rotate inside of the stator. So another main component which you do need within an electrical system is a starter. Part of the starter is quite self-explanatory, and it is to turn the engine over once you have turned the ignition. So I've also put a diagram here as well, so you can see a fairly basic layout of the wiring system. So you've got the battery, you've got the starter right there, you've got the neutral safety switch, and then on top of that as well, you've also got a starter relay as well, which is a safety device, also known as a switch. If you did watch my previous video as well on electrical components, you would have seen that I did talk about those. If you haven't already, I'm not going to talk about it now and what relays are, but if you do go back to my previous video, you can learn more about those as well as some other components as well. And then obviously, as I said before, you do also have the ignition switch, which then effectively connects the whole circuit, and allows the current to go to the starter motor, which then engages, turns, and gets the engine running. So just like the alternator, you can see here I've put a little diagram where you can see the internal components of the starter. So the pinion, which is just located right here, and it's also been labelled for you as well, is part of the starter, which is engineered to fit into the flywheel of the engine where it is driven, and allows the flywheel to turn the engine over. The actuating arm, just here, you can see it is connecting the pinion and also the solenoid. So what basically happens is, with the actuating arm, when the solenoid is engaged, it will then push this spring out, which then also pushes the pinion back in. So as soon as the engine is turned over, it will do the opposite. The spring will be pulled back, the arm will go back, which then allows the bottom part of the arm to then push out the pinion, which then goes into the engine compartment where the flywheel is, connecting the starter and the flywheel together, which then allows the starter to start to rotate the flywheel, starting the engine. And as I said before, I think I may have said that one a bit backwards. So obviously, when the solenoid is then engaged again, it will then pull the pinion back out again once the engine has turned over. So the field windings right here, as you can see again, it is labelled for you. The field windings are what create the electromagnetic field around the motor armature. However, the coil windings do depend on the starter motor itself. Some have more than others due to the size of it. So depending on how big it is, depends on how many you have. So if you have quite a big starter motor, you are going to have more coil windings. Whereas if you have a smaller one, you are going to need a lot less. So the bushes here, as you can see, the bushes are made from a carbon alloy and copper material, which makes it a better conductor, and are actually housed at the back of the starter. Again, along with the solenoid, I did mention it earlier, quite briefly though. The starter it also contains 2 coil windings, which are wrapped around a core. It acts as a switch, which then closes the electrical connection and connects the starter to the vehicle's battery, which then obviously allows the battery to then energise those coil windings, which then allows the starter to operate as it should. Okay, so moving on to the battery side of things. As I said, the alternator is going to be charging the battery, and the battery is going to be energising the starter. So they all kind of work hand in hand, which is why I also wanted to make this video and put all of these main components together. So that way you do have a better understanding as how they all work together. So again, I have put another diagram so you can understand the internal components as well, which are inside the battery. Yeah, you do have the positive and negative terminal at the top here, which obviously allow you to connect the wiring loom to the battery. And if you do need to, you can also use these terminals to charge the battery. Whenever you are disconnecting a battery, it's always best to disconnect the negative first and then the positive, and then vice versa, the other way around. When you are connecting the battery, positive first, then negative. So you've also got some vents as well. You don't always have vents on batteries, but when you do, quite often it's because it is a safety feature which has been integrated into the battery. So it allows the battery to breathe and cool down, because these batteries do get extremely hot, so they are going to need something to help it cool down. So with each of these cells, as you probably do know, it's quite basic common knowledge, you do have a 12-volt battery. But if you really want to get into it, it is actually a 12.6 volt battery. You've got 6 cells. Each of those cells do withhold 2.1 volts, which if you add all those up do come to 12.6 volts. And you've also got some cell connectors and also the cell dividers. And the main purpose for the cell dividers is to obviously divide the cells, but also due to the temperature that these batteries do get at as well. Again, it is another safety feature which allows the cells not to touch one another, because as time goes on, the older the battery gets, the more deteriorated it will get. As it heats up, sometimes you might find that the cells may start to heat up and kind of start to melt or kind of get distorted by the heat. As this does happen, if you didn't have the cell divider, and should both of those cells touch each other, the battery will actually explode. Which is also another reason as well. If you do have a battery charger, make sure that battery charger does have a safety feature whereby it will automatically turn off once the battery has been fully charged. If not, then again the battery will heat up. The cells will then start to touch each other, which is the reason why batteries do explode if you don't monitor them properly. You've also got some lead conductors as well across each cell, which then which one goes to the positive and one to the negative as well. So yeah guys, that's near enough it anyway for batteries. The reason why I haven't spoke about all of the components in great detail was because I thought it might be good, if you do want to do some research by yourself and learn a bit more, then obviously feel free to do that. Yeah, anyway, I'm also going to be moving on to the next thing as well, because I don't want to make this video too long and boring for yourselves. But yeah, I mean, as I said, if you do want to do some more research in your spare time, feel free to come back to this video, pause it, look at some of the components which are in either the starter, alternator battery, or any of the other components which I'm going to be going through in this video. So moving on to spark plugs. Spark plugs are used in your everyday petrol engines, and the main job for them is to ignite the air and fuel within the combustion chamber. And you can also get two different types of spark plugs, which not many people know about. And the reason for that is because the main one, which is used in everyday vehicles, is known as a hot spark plug, which, as I said, it is used in everyday cars. The other one that is usually quite unheard of, unless you are with it, if you are into the automotive industry and quite a bit about spark plugs, then you will also know as well. There is also another type of spark plug called a cold spark plug, and these are actually used in F1 cars, which is obviously the main reason why you may have never heard of them before. So again, with the diagram, I'm going to start from the bottom because it will then explain the reason for the diagram on the left. So at the very bottom here, you've got what's known as the negative electrodes, and the main job for them is to make sure that the spark plug does spark. So you've got the connector right here, which then connects onto the HT lead, also known as a high tension lead. The current will then go through the HT lead, then travelling through the spark plug, going straight through the positive electrode, then travels down, and then finally sparks out of the alloy copper plated electrode. The spark will happen between these two components, the negative electrode and also the copper plated electrode. If there is too much of a gap between these two, then obviously the spark plug isn't going to spark, but if it does, it's not going to be as powerful as it should be. So that brings us on to the diagram on the left hand side. So as you can see from the first, second, third and fourth, you can see that there are one electrode, two electrodes, three and also four. And the reason for that is because over time, a bit like the battery and anything else that you do buy, over time it will deteriorate. As it does get hotter, because it is part of the combustion system, it is going to get immensely hot. So the metal will start to heat up, and the electrode will start to come further and further away from the copper electrode, which then means, as I said before, either the spark isn't going to be as strong as it needs to be to ignite the fuel and air, or there's not going to be any spark at all. So the main purpose for the second, third and fourth is it's sort of like a backup electrode. So if one of them comes too far away, it's always got the second one, or maybe even the third one, or even the fourth one to kind of back it up with. So they are a lot more expensive in terms of retail price, but they do serve a greater purpose for that. And as you can also see as well, it does come with a ceramic insulator, and obviously quite explanatory, to be honest, because the diagram it is there purposely just for the installation. So moving on to coil packs. So as you can see, I've put quite a few diagrams here, as over the years they have changed and gotten a lot better as well. The reason why they've changed it over time is just so you do get better performance, and also there are less components to kind of worry about when it comes to having any faults with them. So I'm going to start off by talking about the distributor. It's not really a coil pack, but it is something that was used before coil packs came along, so I feel like it is a great thing to talk about before going into the coil pack. So I've put like a little diagram here again, and it shows you all the components. Again, I'm not going to be talking about all the components which are in a distributor, as I am going to leave it up to you guys to do a bit of research and just so you can learn in your own time, as we do have quite a lot of time on our hands at the moment due to COVID. So yeah, within the distributor itself, you will have like a little rotor whereby it will turn at the same speed as the engine is turning. So it will allow the current to go through each of the HT leads into the spark plugs. So you'll have like a little spark plug. So then you'll have the HT lead, which will go onto these four sockets here, as well as the one in the middle as well, which is where the current will go through each into the HT leads and then into the spark plugs. And this little bit here is known as the spline, which is the type of fixture that you would get as it goes into the engine, hence why it can get the power from the engine going into the distributor. So moving on to the coil packs, this is like the sort of coil pack that you would normally have found quite a few years ago, mainly in a lot of classic cars. whereby you'll have two winding coils, one which would be primary and the one secondary. It would also be soaked in oil as well, just to keep it cool as well, just so it doesn't overheat and explode or cause any other damage. You've also got this one as well, which is kind of like a distributor as well, as you can tell from the 4 holes that you've got there, and also the ones that you've got on here. So yeah, and then obviously in today's cars as well, these are the type of coil packs that you would normally find. So on top, these are the coil packs right here. I believe, judging by the way that they look, I think these may be the ones from an Audi possibly. As I understand, that Audi do tend to like to, they do like to use the colour red for the coil packs on some of their Audis. So I think that may have been from one of their Audis possibly. But yeah, so as I said before, you've got the coil packs here, and then you will get the wiring loom, which will then connect into the coil pack just there, and then the current will then travel through here, and then into the spark plugs once again, making the spark plugs spark. Pretty much in addition to that anyway, coil packs overall, they are pretty much a replacement for the distributor. It is a electronic controlled pack of ignition coils, which are then regulated by the car's ECU. So yeah, there's not really much to them either. It's quite easy to understand. But yeah, I mean, if you do have any questions about that or any of the other components which I've been going through, feel free to put any comments below, and I'll be sure to get back to you in the comments. So I'm going to be moving on to the final thing, which are glow plugs. So these are kind of like the replacement for spark plugs, but they are used in diesel engines. What they basically do is they will heat up the combustion chambers for diesel engines, as they wouldn't have any other component to ignite the fuel and air. So they do heat up for around 15 seconds or less, and within those 15 seconds they can heat the whole combustion chamber up to 1,000 degrees. Which would then allow for the combustion to then obviously act and allow the fuel in there to then combust. So yeah guys, that is pretty much it for today's video. I hope you enjoyed. And yeah, thank you so much for watching. Don't forget to subscribe, and make sure you click the bell icon as well so you are notified when I do make another upload.